Okay, we're going to try and solve this question, which was the question 7 on the cive1460 summer 2016 exam. You'll see it's in 3 parts. The first part was about working out pressure, giving it in 1 set of units and expressing it in 3 other sets of units. Essentially, you're going to be using let's see, P equals rho G H several times. Question 2 is about working out the force required to open this gate. So its force is on a submerged plane surface. Okay, and question 3 is about the force exerted on the water to turn it round a pipe bend. Okay, right, let's get started. Question 7a, express the gauge pressure. So we want to get this in terms of meters of water. So let's just have a remember what we're talking about. We're talking about P gauge let's start again. This is question 7a. We're going to look at working out the absolute pressure of 120 kilopascals gauge in terms of meters of water, newtons per meter squared, bar, pascals, and meters of mercury, where we're given the relative density. So let's just remember, P absolute equals P gauge plus P atmospheric. Okay, so we have P equals 120 kilopascals, which is the same as 1,000 pascals, and a pascal is the same as newtons per meter squared, so that's 120,000 newtons per meter squared as well. We have our equation for expressing pressure in terms of a head, and that's P equals rho G H. We have H equals then 120,000 divided by the density, so meters of water, so the density of water is 1,000 kilograms per meter cubed times 9.8, which will give us 12.2 meters of water. Okay, in terms of mercury, 120,000 divided by, well, we've got a relative density of 13.5, so it's 13.5 times the density of water, so that's the density of mercury, times 9.8, which gives us 0.9 meters of mercury. So up to now, these two here are gauge heads of pressure, gauge pressure. Let's see, what's the next one? 1 bar equals 10 to the 5 newtons per meter squared. Equals 10, 1, 2, 3, 4, 100,000 newtons per meter squared. Okay. So P equals 120,000 divided by 100,000, which equals 1.2 bar. Now, we were told in the question that the atmospheric pressure, so if P atmospheric is equal to 101 kilonewtons per meter squared, which is equal to 101,000 newtons per meter squared, we can now start to convert the rest, the pressures above into atmosphere, into absolute pressures. So atmospheric pressure in terms of a head would be 101,000 divided by 1,000 times 9.81, which equals 10.3. meters of water. Which equals 101,000 divided by 13.5 times 1,000 times 9.81, equals 0.76 meters of mercury. And in terms of bar, it's 101,000 divided by 10 to the 5, which equals 1.01 bar. So the absolute pressures that we were asked to work things out. In terms of water, the absolute pressure, P absolute equals P gauge plus P atmospheric. So so the pressure P absolute is 120,000 plus 101,000, which equals 221,000 newtons per meter squared, which equals 221 kilonewtons per meter squared, which equals 221 kilopascals. Okay. Meters of water equals 12.2 plus 10.3, which equals 22.5 meters of water. In terms of mercury, equals 0.9 plus 0.76, which equals 1.67 meters of mercury. And in terms of bar, this 120,000 newtons per meter squared is 1.2 plus 1.01, which equals 2.21 bar. Okay, those are all the answers to part A. Okay, let's look at part B now. Now this is a circular gate. Let's just look at that gate as though we were looking in that direction. We see a circle. It says it's hinged at the top here, and we're going to calculate the force acting at the bottom here, which will keep the gate closed, which is equivalent, causes the equivalent moment on this hinge to keep so that red anti-clockwise arrow is the moment that the water is causing on the gate. So if we have a force R acting on the gate from the water, that's causing that moment indicated on that hinge, and we're asking what force F would cause a moment to keep that gate closed. Okay, let's just look again at the circle. We need to know where the middle of the circle is, so that's the centre of gravity, and we're going to calculate the centre of pressure, CP, which will be a little bit below that diagram, that centre of gravity. So let's just draw on here. The R acts at this depth SC. This centre of gravity is at our depth X bar. Okay, let's start working out some things that we need. Right, we need to work out the area of the gate, which is just pi d squared, and d is 1 over 4, which equals 0.785 meters squared. Let's just do that, 854. X bar, from a bit of geometry, is just 2.5 plus half the diameter plus 0.5, which equals 3 meters. So we can now work out the force. R is the pressure at the centroid times by the area. So the pressure at the centroid is rho g x bar, and the area is the area. Okay, which is water, so density of 1000 times 9.8 times 3 times 0.7854, which works out to be 23,090 newtons. Okay. Well, now we want to find this length SC. Now we've got a formula for SC. SC equals IgG over A x bar plus x bar. Now we know x bar, we know A. What's IgG? Well, for a circle, you can look this up, and this would be supplied in an exam. IgG equals pi r to the 4 over 4. And in this case, r is a half, so it's pi 0.5 to the 4 over 4, which comes out to be 0.01. Sorry, 0.04. Oh dear, that's not very clear, is it? 0.0491 units of meters to the 4, but we won't worry about that. So we can put these numbers in to calculate SC. 0.0491 over 0.7854 times 3 plus 3 is equal to 3.021 meters. Okay, now we have to work out the lever arm. So what's the lever arm? Well, let's just have a look at the circle. Here's our gate now. We've got a force F here that we're trying to calculate. We've got a force R acting here. Now we've got our distance SC. We know that that distance to the gate top is 2.5. So the lever arm, let's call this L. L equals SC, which is 3.021 minus 2.5, which equals 0.521 meters. So the moment due to the water, M, so M, I'm going to switch back to blue. I'm going to switch to blue now. M is equal to this lever arm. It's M equals L times R, which equals 0.521 times, let's go back to R, it's 23,090, 23,090, which is in Newton meters, so 12,030 Newton meters. Let's just clear that one out, make it a bit clearer. 12,030 Newton meters. Right, the force, this moment, M, must also equal F times the lever arm, and the lever arm for this one is 1 meter because it's the diameter of the gate. So that equals 12,030. Therefore, F equals 12,030 divided by 1, which is 12,030 Newton meters. Okay, that's part B completed. So the value of F is the value of F that keeps that gate closed. The force to be applied at the bottom of the gate to keep it closed. Okay, now let's have a look at the force on the bend in part C. Well, we've got a bend, a pipe that curves downwards and gets a bit wider. Now this angle, oh dear, that's not very good. This angle is let me try and draw this on here, is 70 degrees. Okay, so we say that the pipe is turned through an angle of 70 degrees. If if the angle here is 0, we've got a 200 millimeter diameter at the entrance, and the exit is 300 millimeters. Now we know that the pressure at this exit, so it's called, label these 0.1 and this is 0.2. We know that P2 is equal to 120,000 newtons per meter squared. We know that the flow in the pipe Q equals 0.07 meters cubed per second. We've got some dimensions on here. It's useful at the beginning to work out the areas and velocities at 1 and 2. Let's just work out A1. I'm going to use pi d squared over 4, which is for A1 0.0314 meters squared. A2 is 0.0707 meters squared. Q equals A1 U1 equals A2 U2 from continuity. Let's work out those velocities. U2 equals 0.07 over 0.0707, which is 0.9902 meters per second. U1 is 0.07 divided by 0.0314, which is 2.228 meters per second. Okay. So these are the basic numbers we need to start with. Let's apply the total force equation, Ft, and in the x direction we'll have rho q. Resolve the velocities in the x direction, so the outflowing velocity is u2 cos 70 minus u1 cos 0. We know cos 0 equals 1. We can work that out, and that comes to minus 138.0 newtons. And in the y direction, the total force is equal to rho q u2 sine 70 minus u1 sine 0, which is 0. And that comes to, well, it's positive, and we'll write the positive, 66.95 newtons. Now we've got the pressure at the outlet, but we're at 0.2. We're going to need the pressure at the inlet. So to get the pressure, we're going to apply the Bernoulli equation. And I'll just write it down. P1 over rho g plus u1 squared over 2g plus z1 equals P2 over rho g plus u2 squared over 2g plus z2. Now this pipe is turning in the horizontal plane. It's not going up or going down. Might look like it's going down the diagram, but it's not. It's in the horizontal plane. So z1 equals z2. So we can cancel those out from this equation. Yep. We know P2, we know U2, we know U1. So we can work out P1. And that turns out to be 118,000 newtons per meter squared. Let's just write down P2 because that's quite convenient. We know this from the given in the question. 120,000 newtons per meter squared. Okay. So the pressure's risen from point 1 to point 2, And we see that that's about right because the velocity has decreased and the pressure has increased. We know that as a useful check. Right, let's work out the pressure forces in the x direction. Fpx is equal to the pressure times the area resolved at the inlet minus the pressure times the area resolved in the outlet. So P1 A1 cos 0 minus P2 A2 cos 70, which equals 808.4 newtons. Fpy equals P1 A1 sine 0, which will be 0, minus P2 A2 sine 70, and that gives us a minus 7972 newtons. Right, there's no body force on this because it's moving in the horizontal. There's only a body force included if the pipe goes up or the pipe goes down. So no body force as the pipe is turning in the horizontal plane. Okay, so Fbx equals Fby equals 0. Right, we've now got all the forces we need to calculate the resultant force. We're going to use this Ft equals Fr plus Fp plus Fb resolved in our x and y directions. So Frx equals Ftx minus Fpx, and I've missed out Fb because it's 0, and that will equal minus 940.7 newtons. Fry equals Fty minus Fpy, which works out to be 8,037 newtons. Let's draw a force diagram. So we've got a negative x direction. So here's my force direction. We've got 940 or minus 940.7. And we've got a positive y direction. So this is much bigger. Probably drawn this wrong. Let me just correct that picture a little bit. So this will be much smaller down there. And this will be 8,037. Okay, let's just draw our vector diagram, and the resultant R equals, sorry, let's use the terminology correctly. This is Fr equals a square root Frx squared plus Fry squared, and this turns out to be 8,092 newtons. And let's just find an angle. Let's just say we're going to calculate this angle to the horizontal. So tan phi equals Fr y over Frx, which goes to phi equals minus 83.3 degrees and this is negative as it's clockwise from the x-axis, so you need to just be clear. By drawing it on the picture, that defines which is the angle. So there's the answers. Okay, thank you.